Welcome to The Explainer. Today, we're diving into something that's, quite frankly, fundamentally shifting the entire AI landscape right now. We're talking about the Model Context Protocol, or MCP. Look, if you've been building or even just tinkering with AI agents, you absolutely know the headache. You spend days writing custom code just to get your AI to read a simple text file, right? Well, today, we are completely demystifying MCP. We'll look at exactly how it works under the hood and why it's rapidly becoming the universal standard for AI connectivity.
Okay, let's dive into this. Think about the before picture. Before MCP, every single time you wanted your AI app to talk to a database or read a local file or hit an API, you had to build this messy, custom integration. It was totally fragmented, it didn't scale. Honestly, a complete nightmare to maintain. But with MCP, it changes the whole game. Now we have one standard protocol. It acts like a universal bridge that works seamlessly across all your tools, all your apps, all your platforms. No more reinventing the wheel every single time.
Now, what's really interesting about this slide is that this infographic is basically our master map for understanding the whole system as it stands today. Over on one side, you've got your AI applications, and on the other, your external systems, your files, databases, APIs, the whole shebang. And right there in the middle, that's the MCP protocol connecting them. We're going to unpack every single piece of this roadmap so you know exactly how the data flows securely from end to end.
So here's our roadmap. 1. The USB-C for AI. 2. Where MCP fits and architecture. 3. How MCP works step by step. 4. Capabilities and key benefits. 5. A real-world practical example. And finally, 6. Under-the-hood technicals. We'll cover every single piece of this puzzle in order.
Section 1. The USB-C for AI.
At its core, the Model Context Protocol is an open standard. It defines exactly how AI applications get context, tools, and data from external sources. Think about the USB-C cable that's probably sitting on your desk right now. Just like USB-C lets entirely different pieces of hardware connect using one universal physical standard, MCP does the exact same thing, but for software. It lets AI models plug into your tools securely and consistently. You know that drawer full of tangled, random dongles and cables you used to need for your monitor, your phone, your laptop? You don't need that anymore. With MCP, your AI doesn't need a different custom integration for Git, or your file system, or your database. It is one universal connection.
Moving right along to Section 2, where MCP fits in architecture. Think of a traditional client-server architecture, but specifically tailored for AI context. We've got three primary components here. First up, the MCP client. Now this lives right inside your AI application, say your IDE or your chat interface. Its main job is to be the requester. It discovers what tools are available and sends out the requests. Second, the MCP server. This one's external. It sits over your data, exposes the tools, and actually executes those requests. And finally, the MCP protocol itself. This is the communication layer, the bridge between the two, using a structured messaging format called JSON RBC 2.0 to exchange data. You can think of JSON RBC 2.0 as a sort of universal translator. It ensures both sides completely understand the data being passed back and forth. The AI never actually touches the raw database directly. It just talks to the MCP client, and the client handles the rest.
All right, Section 3. How MCP works step by step.
And this brilliantly illustrates just how elegantly this flow connects the user to external tools. Let's trace a single request from start to finish. Step 1. You, the user, ask a question. Step 2. The AI model realizes, hey, I don't have the answer in my training data, so it decides it needs external context. Step 3. The AI hands this off to the MCP client, which formats and sends the request over the protocol. Step 4. The MCP server receives it, fetches the data, and runs whatever tools are necessary. Step 5. The server sends back a clean, structured response. Not messy, unstructured text, but clean data. And finally, Step 6. The AI absorbs that structured data and generates an accurate, context-aware response for you. Now, all of this happens in the blink of an eye, but this 6-step handshake is absolutely crucial. It ensures the AI always gets exactly what it needs, securely and frankly, without hallucinating.
Let's look at Section 4. Capabilities and key benefits.
So what does this architecture actually let the AI do? The capabilities of an MCP server are broken down into three specific buckets. First, we have tools. These are the actions the AI can do. This is highly active. We're talking running a shell command, searching a codebase, maybe creating a file. Second, we have resources. These are things the AI can read. This is your passive data gathering, like reading a database schema, fetching API responses, pulling in a piece of documentation. And lastly, we have prompts. These are reusable templates that structure the AI's thinking before it takes action, like system instructions or complex task workflows. By drawing a hard line between what an AI can do, read, and think, developers can build systems that are incredibly safe and entirely predictable.
Because MCP categorizes data so efficiently, the benefits are huge. Standardization means exactly what it sounds like: one protocol for everything. No more spaghetti code of custom APIs. Then there's interoperability, which is a real game changer and exactly why the industry is adopting this. An MCP server written in Python can talk to an AI app written in TypeScript seamlessly. It's totally language agnostic. Security is also paramount. The external server dictates exactly what the AI can and cannot access. Extensibility? You can plug in a new tool as easily as plugging in a USB mouse. That literally saves your dev team weeks of writing custom API bridges. And of course, it supports both local and remote setups, so it works securely on your local machines files or all the way across the internet to cloud APIs.
Section 5, a real-world practical example. Let's move to our scenario and see how this builds. We're going to bring these abstract concepts down to earth with a concrete, everyday developer scenario. Imagine typing this exact prompt into your AI assistant. Summarize my latest Git commits and create a changelog. Sounds like a simple request, right? But historically, an AI just couldn't do this. It couldn't safely and easily see your local Git repository, nor could it read your project's changelog templates.
But with MCP running, it's like pure magic internally. The AI receives your prompt and instantly realizes it needs two things. First, it reaches out through the MCP client to a Git server on your machine to pull the latest commit history. At the exact same time, it queries a completely separate file system server to read your specific changelog template files. It pulls the read-only data from both of these totally independent MCP servers, combines the context perfectly, and boom, it outputs a properly formatted changelog exactly the way your team likes it. One single prompt, two entirely different data sources flawlessly integrated in seconds.
Finally, Section 6, Under the Hood, Technicals. So how does this actually communicate behind the scenes? Seriously, let me ask you, if you were designing a protocol that had to work safely and quickly across literally any programming language on Earth, how would you ensure they communicate properly without the whole thing breaking? Well, the answer lies in flexible transport methods. To move messages around, MCP supports 3 main transport layers, all tied together by that language-independent JSON RPC 2.0 we mentioned earlier. First, Stedio is used for local processes running directly on your machine. Think of Stedio like passing a note to a coworker sitting right next to you. Then you have SSE, or Server-Sent Events. This handles real-time streaming updates, like a live ticker tape of information constantly flowing in. And standard HTTP is used when making remote calls. That's exactly like packing up a box and sending a package across the internet. Plus, there's a baked-in discovery phase. When a client connects, it literally pings the server and says, "Hey, what tools do you have?" And the server responds with a full menu of its capabilities. It's entirely self-documenting, which is brilliant.
Now, of course, if an AI can run shell commands and read local databases, the security has to be absolutely ironclad. And it is. The MCP security model is strict. It operates entirely on the principle of least privilege. Because the MCP server handles the actual request, not the AI app itself, the server acts as a strict nightclub bouncer. It alone decides what data gets through the door. No unnecessary data is ever exposed to the AI model, unless it is explicitly requested and authorized by the server's configuration. So whether you're running a local environment or hitting massive enterprise cloud servers, that security is baked right into the foundation by default. So the crucial point is perfectly summarized by this quote from our source material. MCP turns AI from just answering questions into actually doing useful work with real systems. We are officially moving beyond the era of AI acting as just a smart chatbot that guesses at code or text. By utilizing the Model Context Protocol, AI becomes an active, highly capable agent. It's equipped with the right tools, it's reading the right real-time data, and it's executing commands safely within your established environments.
I want you to think about the cascading effect of the standardization. If building an MCP server is open and accessible to anyone, and MCP truly becomes the universal USB-C for AI systems, what happens when every single developer tool, database, and software platform in the world is finally plugged in and speaking the exact same language? I'll let you ponder that incredible potential. Thanks for joining me for this explainer, and I'll catch you in the next one.